You know, a single straight line seems pretty simple, right? But what if I told you it's actually telling a powerful story, a story of constant, predictable change? It's the secret behind everything from your taxi fare to your phone's battery drain. And by the end of this, I promise you're going to see these stories absolutely everywhere. Okay, so let's jump right in with something we've all wondered about. You hop at a taxi, you see that meter start ticking up, but what's really going on there? What's the secret rule deciding what you're going to pay? Well, guess what? It's not some big mystery. It's a perfect real world example of a straight line story. All right, check out this table. See that? At 0 miles, before you've even gone an inch, it costs $3. Bam, that's your starting point. Then, for every single mile you go, what happens? The cost goes up by exactly $2 every single time. That steady, predictable jump, that's the engine driving this whole thing. And get this, those two numbers, the start and the change, that's literally all we need to know. Okay, so let's really break this down. Every straight line has like a secret code. You could even call it its DNA. It's made of just two key ingredients that basically map out its entire journey from start to finish. So, first up, we've got the y-intercept. Now that sounds all technical, but don't worry, it's just the starting point. Seriously, that's it. For our taxi, it's that $3 flat fee, right? The cost before you even start moving. On a graph, it's just where does the line hit that vertical axis? That's your y-intercept. It's the beginning of the story. And the second ingredient, that's the slope. This is the fun part. The slope tells us how steep the line is. It's the action. It answers the question, how fast is this thing changing? In our taxi example, the slope is that $2 charge per mile. It's what makes the price climb. The steeper the slope, the faster the change. Simple as that. And what's really cool is that the slope's direction tells you the whole vibe of the story instantly. If it's a positive slope, we're climbing uphill. Think growth, like our taxi fare getting bigger. If it's negative, we're heading downhill. Something's decreasing, like your phone battery draining. A zero slope, that's a flat line. Nothing's changing. Total stability. And that crazy vertical line, an undefined slope, that's like an infinite, impossible change all at once. All right, so we've got our two ingredients, the start and the rate of change. Now, let's put them together and look at the master recipe for any straight line out there. And there it is, the famous y equals mx plus b. This little equation is everything. It's the master recipe. If you know m, your slope, and b, your starting point, you literally know everything about that line. It's the whole story in one short sentence. And drawing this on a graph? Super easy. It's just 3 steps. Step 1, put a dot on your starting point, b, on that vertical axis. Step 2, from that dot, use your slope, remember, rise over run, to find a second dot. And step 3, just connect the dots with a straight line. Boom, you've just drawn the entire story. Okay, so we know the recipe. Now, let's flip this around. Let's become detectives. Instead of building the line from the equation, we're going to find the equation just by looking at the clues. So, what if all you have is the picture, just a line on a graph? How do you work backwards? How do you figure out its secret formula, that y equals mx plus b equation, just by looking at it? It's a pretty straightforward strategy. First thing you do is find the starting point. Just look at where that line crosses the vertical axis. That's your b. Done. Next, you need the slope, your m. Just pick any 2 points on the line and count the rise and the run between them. Once you have your m and your b, you just plug them into the formula, and you've cracked the code. All right, let's try a different kind of puzzle. What if there's no picture, no graph? All you've got is a table of numbers. How in the world do you find the straight line story hidden inside that data? Okay, the process here is a little more number crunchy, but it's totally logical. First, you find the slope, m, by picking any 2 points from the table and using that little formula, change in y divided by change in x. Once you've got your slope, you can take any point from the table, plug it and the slope into y equals mx plus b, and solve for b, your starting point. It's like a guaranteed method for finding the story hidden in the numbers. You know, lines can have special relationships too. Take parallel lines. They're like train tracks, right? They go on and on forever, but never ever cross. Why? Because they have the exact same slope. Then you've got perpendicular lines. Think of the corner of a street. They meet at a perfect 90-degree angle. And their slopes? They have this cool relationship where they're opposite reciprocals. totally connected. So you might be thinking, okay, this is cool math, but why does it matter in the real world? Well, here's why. Because once you can describe something with one of these equations, you unlock a superpower. You can make predictions. You can literally see into the future. Let's put that superpower to the test right now. Picture this, a big 20-kilogram block of ice. It's melting at a steady rate, losing 2 kilograms every single hour. Can we write its story? Can we predict its future? Let's build the equation. First, what's our starting point? Our b? Well, it starts at 20 kilograms. Easy. Now, what's the rate of change, or slope m? It's melting, so the weight is going down. That means our slope has to be negative, -2. So we put it all together, and we get our equation, y equals -2x plus 20. And now for the magic. With this little equation, we can predict anything. Let's say we want to know how much ice is left after 5 hours. We just plug in 5 for x. So -2 times 5 is -10. Add 20, and you get 10. After 5 hours, there will be exactly 10 kilograms of ice left. How cool is that? Simple, precise prediction. And this whole idea, this constant change, it shows up everywhere in math. It's basically the same thing as an arithmetic sequence, where you just keep adding or subtracting the same number over and over again, like 20, 18, 16. One is a picture, the other is a list of numbers, but they're telling the exact same story. So at the end of the day, what's the big takeaway here? It's that this stuff isn't just for a math test. It's a real tool, a way to understand and make sense of the world around you, whether it's your money, your travel time, you name it. It's the language of constant change. So I'm going to leave you with a question to chew on. What in your life follows a straight line? Maybe it's how much you save each week, or how your phone battery drains during the day. Seriously, start looking for these patterns, because I guarantee once you start looking, you will see the simple, powerful story of a straight line absolutely everywhere.